Right now, as you are watching this, the National Hurricane Center's official outlook, issued at 2 in the morning today, states plainly that no tropical cyclone formation is expected anywhere in the Atlantic, the Caribbean, or the Gulf over the next 7 days. And yet, in the same breath, meteorologists at multiple forecasting outlets are telling their audiences to keep an eye on the Gulf because the water sitting beneath that calm forecast is running 2 to 4 degrees Fahrenheit warmer than average. A current called the loop current is reorganizing itself in a configuration that has historically fueled some of the fastest intensifying hurricanes on record. And the conditions currently suppressing storm formation are expected to weaken during the second half of this month. So which is it? Is there nothing to worry about, or is there something worth paying close attention to? The honest answer, and the reason we are doing this video, is both, and understanding why both of those things can be true at the same time is actually the most useful thing you can learn about how hurricane risk actually works. No hype, no manufactured panic, just what scientists are actually monitoring and why. Drop a comment and tell me if you live anywhere along the Gulf Coast, and if so, what this hurricane season has felt like so far. I read every one of these. If you want grounded breakdowns of weather risk instead of panic bait, subscribe, it is free, and a like helps this reach the people who actually need to see it before a storm. Not during one. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. Let us start with exactly what is being monitored right now, because precision matters here. As of this morning, the National Hurricane Center's tropical weather outlook for the Atlantic Basin, which includes the Gulf, explicitly states that tropical cyclone formation is not expected during the next 7 days. That is an official, current forecast, not a guess. At the same time, multiple meteorological outlets reporting within the last day have noted that forecasters are specifically watching an area near the Gulf Coast for possible development later this week, with the greatest attention on Florida's panhandle and nearby portions of the southeast. The reason those two statements are not actually in conflict is that hurricane forecasting works in layers. The 7-day outlook tells you what is likely to organize into an actual named system in the immediate term. Longer range monitoring is about tracking the ingredients, the warm water, the wind shear, the moisture, that make a region either favorable or unfavorable for something to form once a disturbance actually shows up. Right now, the ingredients in the Gulf are shifting toward favorable, even though no specific disturbance has yet. Organized into something the National Hurricane Center is tracking by name. To understand why the Gulf specifically gets this kind of attention every single year, you need to understand what has been happening to the water itself. According to research highlighted by Yale Climate Connections, sea surface temperatures in the Gulf during summer months have been climbing at roughly double the pace of the rest of the world's oceans since 2012. That is not a small statistical footnote. Record high Gulf temperatures were set in 2024 and again in 2025. And near record warmth has persisted into this year as well. Scientists comparing the past 10 winters to the 10 winters before that found something striking. The most recent decade averaged about 0.8 degrees Celsius above normal in Gulf Sea surface temperatures, compared with only about 0.2 degrees above normal in the decade before it, roughly 4 times the anomaly. Researchers suspect that a powerful El Niño event back in 2015 and 2016 may have triggered a longer-lasting shift in how the Gulf behaves thermally, and with a new El Niño developing this year, potentially comparable in strength, scientists are watching closely to see whether the Gulf undergoes another such shift, though they are clear that this remains uncertain rather than confirmed. Layered on top of that broader warming trend is something called the loop current, a powerful ribbon of warm water that flows up from the Caribbean, loops through the eastern Gulf like a horseshoe, and eventually exits through the Florida Strait into the Atlantic. This current moves at roughly 0.8 meters per second, making it one of the fastest currents anywhere in the Atlantic Ocean basin. Periodically, the loop current sheds a massive ring of warm water called an eddy, and when a hurricane crosses over one of these warm eddies, it can draw enormous additional energy from it. According to reporting from earlier this year, the loop current shed one such ring back in February and has already been regrowing northward since, a configuration that specifically favors releasing another eddy during peak hurricane season, which would raise the odds of rapid intensification for any storm that happens to cross its path in the coming months. This is the part of the story that actually explains why scientists take Gulf monitoring so seriously, even during quiet weeks with no named storm on the map. A hurricane's strength depends heavily on how much heat energy it can pull from the ocean surface beneath it. Under ordinary conditions, a hurricane's own powerful winds churn up colder water from deeper down, and that colder water rising to the surface acts as a natural break, cooling the storm and limiting how much stronger it can get. But when the warm water extends deep below the surface, sometimes 100 meters or more, that braking effect essentially disappears, because the storm's winds just keep stirring up more warm water instead of cooling water. This is precisely the mechanism that allowed Hurricane Helene to explode from a Category 1 storm to a Category 4 storm under a single day in September of 2024, according to NASA's satellite analysis of the event, as it crossed unusually deep pockets of warm water in the Gulf. A rapid attribution study conducted around that same period found that the record-breaking ocean temperatures which helped fuel Helene had been made somewhere between 200 and 500 times more likely because of human-caused climate change. Weeks later, Hurricane Milton underwent one of the fastest intensification processes ever recorded in the Atlantic basin, and a separate rapid attribution analysis found that the specific ocean temperature records behind it had been made between 400 and 800 times more likely by climate change. This is not a new phenomenon invented by recent climate headlines either, which is worth being upfront about. Researchers studying Hurricane Katrina back in 2005 found that the storm crossed a distinct warm patch in the northwestern Gulf Shelf adjacent to Louisiana, where sea surface temperatures reached roughly 33 degrees Celsius, an anomaly of about 0.8 degrees Celsius above the surrounding water at the time. Katrina intensified from a Category 1 storm on August 25th of that year all the way through Category 2, 3, 4, and finally Category 5 in the days that followed. And researchers calculated that the heat contained in that abnormally warm patch of Gulf water was comparable in scale to the latent heat being released inside the hurricane itself. In other words, the mechanism we are describing today, warm Gulf water directly fueling rapid strengthening, is not a new discovery. It has been documented and studied since at least the mid-2000s. What has changed is the frequency and depth of that warm water, and therefore how often storms now encounter conditions capable of producing that kind of dramatic, fast strengthening rather than it being a rare one-off occurrence. Peer-reviewed research published in the journal Communications, Earth and Environment looked systematically at this relationship across decades of data rather than just individual storms. Researchers found that approximately 70% of hurricanes that formed in the Gulf of Mexico between 1950 and 2022 were influenced by what scientists call marine heat waves, sustained periods of unusually high sea surface temperature. More importantly, they found that rapid intensification specifically is, on average, 50% more likely to occur during one of these marine heatwave periods compared to normal conditions. And when researchers looked at United States landfalling storms since 1950 that strengthened by at least 40 miles per hour of wind speed within the 24 hours before landfall, one of the most dangerous behaviors a hurricane can exhibit because it leaves almost no time for last-minute evacuation. They found that 5 of the 10 fastest examples in that entire 70-plus year record occurred within just the past 9 years. Now, here is where we need to be careful and honest, because this is exactly the kind of nuance that separates a grounded breakdown from a fear-driven one. NOAA's own seasonal models for this year suggest that Gulf temperatures during this hurricane season will actually fall short of the extreme records set in 2023 through 2025, even though they remain exceptionally elevated by historical standards. Forecasters have also slightly lowered their overall Atlantic hurricane outlook for this year, specifically because the developing El Niño tends to increase wind shear across the Atlantic and Caribbean, an atmospheric condition that generally makes it harder for storms to organize and strengthen in the first place. Current seasonal outlooks call for somewhere between 8 and 14 named storms this year, which is a below-average total. Interestingly, forecasters note that this same El Niño pattern is having close to the opposite effect in the eastern Pacific Basin, where conditions are becoming unusually favorable, with the basin already producing 4 named tropical storms by the middle of July, well ahead of the Atlantic's pace this season. So, the honest picture looks like this. Fewer storms are likely to form in the Atlantic and Gulf this year than in an average season, largely thanks to El Niño-related wind shear. But the Gulf water that any storm which does manage to form will be crossing remains unusually warm, and the loop current is currently positioned in a way that raises the odds of rapid intensification for whichever systems do get through. Fewer storms, but a real chance that the ones that do form behave more dangerously than their initial forecast might suggest. That is a genuinely different risk profile than either a purely quiet season or a purely dangerous one, and it is exactly the kind of nuance that gets lost when a headline just says a major storm is coming or nothing is happening. There is also a hazard here that has nothing to do with wind category at all, and it is worth understanding because it has already played out once this season. Back in June, a system that would become Tropical Storm Arthur, the first named storm of this Atlantic season, formed just offshore of southeast Texas with sustained winds of about 40 miles per hour, a relatively modest, low-end tropical storm by wind speed alone. But meteorologists at the time emphasized repeatedly that the storm's name and wind category were almost beside the point. The system dumped a widespread 5 to 8 inches of rain, with isolated totals reaching as high as 15 inches, triggering dangerous flash flooding across the Texas coast, Louisiana, Mississippi, Alabama, and the western Florida panhandle. In Kerr County, Texas, emergency management officials were, at that very moment, in the process of finalizing new standard operating procedures for an entirely new outdoor siren network, a direct response to the previous year's devastating flash flooding along the Guadalupe River. That timing is not a coincidence. It reflects a broader pattern meteorologists have been emphasizing for years now, that rainfall and flash flooding, not just wind speed, have become the primary hazard for many Gulf systems, including ones that never become powerful hurricanes at all. There is one more piece of the Gulf warming story worth understanding, because it actually offers a rare bit of longer-term good news buried inside all of this. Researchers studying the broader ocean circulation patterns that deliver warm water into the Gulf in the first place, published in a 2023 study, suggested that the rate at which that warm water is being funneled into the Gulf may begin to ease within about 5 years, as the specific ocean gyre expansion driving it starts to moderate. That would not reverse the heat that has already accumulated in the Gulf over the past decade, and it would not undo the deeper warm water layers currently in place. But it does suggest that the current acceleration in Gulf warming may not continue indefinitely at its present pace. Scientists studying this are careful to describe this as a possibility worth watching rather than a confirmed turning point, since ocean circulation systems this large are difficult to predict with precision even a few years out, let alone further into the future. So, what does this actually mean for you if you live anywhere along the Gulf Coast, or honestly anywhere that Gulf moisture regularly reaches? First, do not use the absence of a named storm on a map as your only signal for whether you need to pay attention. As we just covered, some of the most damaging recent events have come from systems that either never reached hurricane strength or intensified so quickly that the wind category changed dramatically within the final day before landfall. Second, know your evacuation zone and your county's alert system before hurricane season is actively threatening you, not during the 48 hours before a storm arrives, since, as Kerr County's own recent history shows, warning infrastructure itself has often still been built out even now. Third, if a system does form in the Gulf this season, treat the rainfall forecast with at least as much seriousness as the wind forecast, since flash flooding has proven repeatedly capable of causing fatalities even from storms that technically stayed below hurricane strength. Fourth, if you ever hear a storm described as undergoing rapid intensification, treat that phrase as a serious warning in its own right rather than just technical jargon, since it specifically describes the exact scenario, a jump of 40 miles per hour or more in wind speed within 24 hours, that leaves communities with the least possible time to prepare. It is also worth understanding why the Atlantic and the Eastern Pacific are behaving so differently from each other this year, because it says something important about how these forecasts get made in the first place. The same El Niño pattern that tends to increase wind shear over the Atlantic and Caribbean, suppressing storm formation there, tends to do close to the opposite over the Eastern Pacific, creating an environment more conducive to tropical development. Forecasters have described the Eastern Pacific Basin as poised to ramp up rapidly this year, and multiple systems have already been organizing off the coast of Mexico and further out to sea, including a system several hundred miles south of Mexico that forecasters gave a 60% chance of developing into a tropical depression by the end of the weekend, and a separate area of disturbed weather southwest of Hawaii, given a 50% chance of development over roughly the same window. None of those systems threaten the Gulf directly, since they are forming in an entirely separate ocean basin, but they illustrate a broader point worth remembering anytime you see a seasonal outlook. The same large-scale climate pattern can suppress storm activity in one ocean basin while actively encouraging it in another, which is exactly why forecasters increasingly talk about global tropical activity as a connected system rather than treating each basin as an isolated story. Here is the honest, grounded summary, and it is also why this story genuinely is not the kind of terrifying imminent disaster headline it could easily be turned into. As of today, no tropical cyclone formation is expected in the Gulf over the next 7 days, according to the National Hurricane Center's own official outlook. Nobody credible is telling you a major hurricane is currently bearing down on anyone. What scientists are actually monitoring is a set of underlying conditions: unusually warm Gulf water extending unusually deep below the surface, a loop current positioned to potentially shed another energetic eddy during peak season, and atmospheric suppressors like wind shear and Saharan dust that are expected to weaken as July continues. None of that guarantees a major storm. It means that if and when a system does organize in the Gulf later this season, the physical ingredients for rapid, dangerous intensification are more present than they would be in an average year. That is precisely why this gets called monitoring rather than warning. Scientists are watching the ingredients, so that if a disturbance does show up, forecasters and emergency managers already understand the environment it will be moving through, rather than being caught off guard the way rapid intensification has caught communities off guard before. We are going to keep tracking this the same way we have covered everything else, sourced directly from the National Hurricane Center, NOAA's seasonal outlooks, and peer-reviewed hurricane research, not recycled panic from other channels. Subscribe so you do not miss it if a system actually does organize in the Gulf this month, because if the ingredients we just walked through do come together, this could move fast. And leave that comment below. Tell me where you are watching from and whether this hurricane season has felt different to you so far. Because behind every one of these forecasts is somebody deciding whether to fill up their car, board up a window, or just go about their week like normal. 5,000 likes on this one. Let us go. See you in the next one.